But now we have a way to actually pass further this correlation ID or any kind of metadata that we want to pass along with our message. Hey guys, it's Peter from DevMentors and welcome to the 10th episode of Building FeedR Microservices.NET 6.0 based series. In this episode, we are going to talk about the correlation. So, what is correlation all about? Simply put, is a way that we actually really need within our system to be able to somehow track and identify the requests and the messages that might be a part of some bigger workflow behind the scenes. Imagine the following scenario. Let's say we have some kind of end user of our app which sends the simple HTTP request to our API gateway, something like, let's say, create order, whatever. And then our API gateway would redirect this specific request, let's say, for example, to order service. And then imagine that as we go along with this simple use case, our order service might actually need to maybe pull some customer data from another service. And then when the order is created, it could publish some kind of event, something like order created. And then maybe other microservices would react to this event. Maybe these other microservices would handle this event. And maybe during handling this event, this order created event, which was actually originated by this create order request sent from our API gateway, the other microservices could, for example, once again pull some data, publish some other events based on this bigger workflow, which originated with this very simple create order request. So there might be like a lot of microservices potentially involved in something which looked to be very simple. And especially in a microservices-based system, we need a way to be able to track and identify this. Because especially when the things start falling apart and when there are bad things happening within our distributed system, if we cannot track, for example, what was the original request, which microservices took part along within this workflow, well, we are pretty much screwed. So we need a way to somehow be able to track this. And we can use the so-called correlation ID. So we'll simply make use, for example, generate some kind of unique identifier that we could apply once, for example, when the API gateway receives its requests from the end user, and then we need to find a way to pass it in both scenarios. The synchronous, in which our services talk to each other, for example, using HTTP clients, HTTP requests synchronously, and asynchronous when they pass the messages, for example, using the message broker. All right, let's start with our gateway, because this is going to be the place which is actually responsible for forwarding all the requests further to the microservices within our distributed system. So somewhere here within our YARP gateway, let's just call this add transforms. So in one of the first episodes where we talked about the YARP gateway, we actually added something similar just to see how these transformations could work. So I'm going to simply call this request transforms, and I want to actually add the new request transform. So the transform will be a very simple one. I'm just going to, let's say, generate the correlation ID. Let's assign the new value by using a GUID, new GUID to string. And then let's just call transform proxy request. And I just want to add this correlation ID to the request header. So I'm going to, let's say, call the request header correlation ID, and I'm going to add this specific uniquely generated value for my new correlation ID for this request. So this is it. Now, once you have this in place, now let's, for example, try it out. So I'm going to jump into one of these feeds microservices, for example, the quotes microservice, and somewhere here, let's just include the following, let's just add the following code. So at first, I'm going to extend this one with the HTTP context. So I want to be able to access this HTTP context, which is unique, of course, within this HTTP header lifetime scope. And here I can do something as simple as request headers, and then I will try to get the value for the same header, which I set within my gateway. So I will ask for my correlation ID header value, and let me just try to get this value as long as this value is actually available. So let's put a few breakpoints here and there, and let's start our gateway and our quotes feed. So I'm just going to put a breakpoint here within our gateway, and I have another breakpoint here within our quotes microservice. So let's start these two services, and let's just see if this is going to work as expected. All right. So let me make a request. I'm just going to jump into our quotes REST file. Let me just change this URL to actually hit the gateway first. And this is going to be fits quotes as our base URL. And then I'm going to hit our pricing start. All right, so this should be, of course, quotes like this. And let me hit this one. So as you can see, we are hitting our gateway, the correlation ID 314. And now we are hitting our quotes microservice through the gateway, and there is our correlation ID 314. So far, so good. Very simple stuff. Now, let's see what we can do, what we can do better, or what we can do more with this correlation ID. So one of the first ideas that you might have in mind is to actually, for example, put these names, maybe put some kind of simple middleware into some shared reusable component, because as you can imagine, most likely we'll like to have all the microservices have them reusing the same correlation ID concept, because later on we might start sending requests or messages between the microservices, and we still want to be able to somehow pass through this original correlation ID set by the gateway in the first place. So luckily, we have our shared project in place. So let's just jump here. And actually, I'm going to create a new directory here, as you might have guessed. I will call this one observability, although the correlation ID per se, doesn't really have that much in common with observability yet. But on the other hand, I would say that's probably one of its kind of core components, because if you don't have a way to somehow correlate your requests, your messages, whether this is synchronous requests or whether these are asynchronous requests, whether these are event-driven, message-based handlers, you need some kind of correlation ID, some kind of identifier that you can pass along. So I'm just going to put this under this observability directory, which of course later on could be extended with the actual pillars of observability, like centralized logging, like tracing, metrics, alerting, monitoring, all this stuff. But let's just start simple. So we're going to simply add here a new static class, the extensions. And as you might imagine, let's just simply extend this class with some simple yet useful features. So the first one will be our very simple kind of middleware. So I'm going to call this one use correlation ID, just like this. So use correlation ID will do the following. So I'll make this one an extension method so we can register this easily across all the microservices whenever we want to use this. And I'm just going to declare here a very basic, even anonymous kind of middleware. So we have our context, we have our next step, and within the whole chain of the available middlewares. And what I will do is the following. So at first, I will try to get my correlation ID from the header. So I will take this header value, and let me just put this somewhere here, for example, as the const or static read only fields. I'll just call this one correlation. Let's make it like this: correlation ID key equals correlation ID. Okay, so we can reuse this across different methods. So I will try to get my correlation ID header from the ongoing request. So let's try context request headers and then try get value. So I'll try to get my correlation ID. And if it's present, that's great. However, if my correlation ID isn't present, maybe I'm within the scope of the direct microservices communication. Maybe it's not the end user talking to us through the gateway, which generates this ID, but maybe this is one microservice talking to another microservice internally. Then in that case, I'm just going to, for example, create this correlation ID here automatically. However, if the correlation ID is passed to me whether this is through the gateway or whether the existing microservice has already received this correlation ID from another microservice and just passes this through to other services, that's fine. What I want to do here is something like, I would like to somehow cache it, store it within this available items kind of directory. So within the lifetime, within the scope of this HTTP, let's say lifetime, I want to keep this correlation ID available. So I can even reuse the same correlation ID as my key for the internal storage of this correlation ID value. And let's just store it here like this, correlation ID to string. And then I can move to my next step of the whole middleware chain. So this is going to be my use correlation middleware. Now let's make here some additional extension. So the next one will be the following. So let's do something like get correlation ID. And this one will try to, for example, pull the correlation ID from our ongoing request. So there is our context. And then I will simply try to do context, items, and then try get value. So for our correlation ID key, I will try to pull this correlation ID value. If it's present, that's great. I know that this value is a string, right? So I can just make this cast. If it's not a string, I can just return a null or default, whatever. And I can mark this one using this additional question mark. So it can be also this nullable reference type here. So if it's not present, I'm just going to return the null. Now let's make one more extension and let's call this one add correlation ID. So I'm going to add the correlation ID to our request headers. So whether this is going to be the gateway here or whether this is going to be our HTTP client talking to another service, I would like to somehow include this correlation ID header just to pass it further to the other services through this HTTP call. So there is my headers collection, there is my correlation ID value. So I'm simply going to do something like we did here within our gateway, which is these headers and then calling try add without validation. There is our header value, which is once again this correlation ID, and there is our actual correlation ID value. So I can actually already fix this to use the following extension, add correlation ID. So now I am certain that I'll be reusing the same header everywhere. So I will not make any mistakes by trying to memorize this magic correlation ID string. I have this stronger type here and I can use this method. And also within our quotes, what I can do now here is instead of trying to pull this correlation ID this way, I can do something like correlation ID and then context and call our get correlation ID extension method. Okay, so let's give this one a try. Let's see if this refactoring will help us in some way. And let me just put a few breakpoints here and there. And hopefully this should work. So the effect will be still the same as we have seen before. However, in this case, we did some refactoring. So now you can use it anywhere and you don't have to worry about remembering this string for the headers or this key for your items caching per HTTP request and so on. So yeah, let's make another request. Let's see if this is going to work. All right. So at first, once again, creating our unique correlation ID 0 to 6. Now adding this to our request headers. And now we are hitting our map post. And one more thing that we need to do is actually we need to call our middleware, because in this scenario, if I just let it go, you will see that our items dictionary is empty. We have no result, so our correlation ID is empty. So we just have to remember to always include this middleware. So simply here, before we build our app, we can just call this use correlation. So yeah, use correlation ID like this. And now let's just run this once again. So I'm building this and I'm just now I'm adding this middleware to my codes microservice. So let's just run this once again. And now you should observe that we will hit our correlation ID middleware. So let's just make this post request once again. Okay, collation ID. We are adding our 030 value. Now we are hitting our quotes microservice. And as you can see, we are pulling this from our request headers. So if I take a look at this collection, there is our collection ID with the same expected 030 value. And we are now caching it, kind of storing it per this HTTP request within the scope of the lifetime of this unique HTTP request. And now when we hit this method, you can see that within our items, we can find this correlation ID. So we can easily access this correlation ID whenever we have an access to the actual HTTP scope. However, that all looks good, and then it's all fine for the HTTP request scope. Now keep in mind that of course whenever we make additional calls between the services, just like we did in our gateway here, where we included this request correlation ID header to our original, let's say, request, so that later on we could easily pull this here within our, let's say, quotes or other microservice, we would actually need to remember, for example, about our HTTP client extensions. So let's say when we register our HTTP client by calling this HTTP client method, we would also have to remember about extending our HTTP client with this correlation ID request header. Okay, we could easily do this by, for example, registering some kind of delegating handler, this is HTTP message handler, where we could just pull this correlation ID from the ongoing request and include it by default. So this will be also kept in a single place. But there is more than just plain HTTP communication, which ideally should be avoided when possible. We should really look forward building the event-driven, asynchronously integrating microservices. So we should really opt for messaging whenever possible. Okay, now let's think about our messaging. So let's jump into our, for example, Pulsar message publisher or subscriber. And as you can see here, we are also using the messaging for different kind of scenarios, right? For this asynchronous messaging. So the question is, how could we pass through the same correlation ID? Because this is the place where we actually lose our HTTP scope. For example, here, when we make a publish async, even though it could be, let's say, as a method, it could be invoked, it could be called within the, it could be invoked within the scope of the HTTP request, it doesn't always have to be the case. Because, for example, in this scenario, we are just subscribing to some kind of stream being sent through our Redis. So as you can see, there is no HTTP lifetime scope. There is no HTTP request. But even if it was within the HTTP request, still within our Pulsar message publisher, we are now, for example, publishing some kind of a message through the message broker. So there is no HTTP context scope. There is no HTTP scope. And on the other side, when we receive this message, for example, for this Pulsar, by using this message subscriber, whether this is going to be Pulsar, Kafka, RabbitMQ, or any other kind of service bus, message broker, or event streaming tool, we are outside of the HTTP scope. And we still want to pass through this correlation ID. Because you can imagine a scenario where, for example, we hit our gateway, we send this request, let's say, to our quotes microservice, we start our pricing somewhere here in the background. If you remember, we have this start pricing command, and we have some background service that will start the pricing. And now we don't know what's going on. We have just lost our correlation ID because we have limited ourselves to be only able to handle the HTTP scope, while there are some messages going on. So we also want to be able to pass this correlation ID across the different services if we are using both the synchronous communication and the asynchronous integration for the events. Now, there are multiple ways to actually pass along this event, this correlation ID, or any other kind of message metadata. So I think we can take a look at one of the most basic ones, and I think also one of the most popular ones that you will find in plenty of libraries out there. So let's jump into our definition of the message publisher and into the definition of our iMessage subscriber. So what we can do is something like, for example, the following. Let's add here a new class, and I'll call this one message envelope. And message envelope like this. We could even make this one a record type, all right? So the message envelope will do the following. So it will accept any kind of T, let's say T message, and we'll also include here some kind of message metadata. So for example, the correlation ID. But as you can imagine, we could also put here some kind of maybe timestamp, maybe some kind of the message ID, whatever you can think of. Or you could even make another structure record class out of this message metadata. So the core idea is that we are now going to provide this kind of wrapper to our original message so we can pass along some additional metadata which aren't really part of the message, because this is more like this infrastructural cross-cutting concern, but we still want to be able to somehow maybe access this correlation ID or other message metadata in order to do some logging, auditing, metrics, tracing, and so on and so on. So let's just do here a very simple constraint. We want our T to be, of course, of iMessage type to implement this simple interface. And now we can extend our message subscriber definition to actually expect within our message handler the message envelope of T. And let me just fix our subscriber here. And let me also fix our subscriber, the actual Pulsar subscriber that we are going to use soon. Now let's remain within our Pulsar message subscriber. So let's see how we could actually consume this correlation ID. So you should be aware now that we can pass this additional metadata through, for example, Pulsar. Just like we can pass the metadata, for example, for RabbitMQ and the AMQP headers, and by using other message brokers as well. So let's imagine that we'll expect that within our Pulsar message metadata, there will be the custom property with the key correlation ID. So something very similar to our HTTP header, but in this case, we are simply going to take this correlation ID value from our message metadata being passed along using Pulsar or any kind of other message broker. And now within our handler payload, so I'm just going to do something like, I want to pass my message to the handler, but this is going to be, of course, the message envelope, and there will be our original payload, and there will also be our correlation ID along with it. And for now, we have only a single consumer, single message broker, let's say consumer. We have our notifier service, so we can easily refactor this one to subscribe async to this guy. And within our message, as you can see, now this is our wrapper, right? So within our notifier, what we can do is the following. We can simply just take a look at our message, and then there is our message as a payload, and then there is our correlation ID. So let me just rename this one to be, let's say, the message envelope, and then there is our original message, okay? And then there is our message symbol, and we can also extend this one with the correlation ID. So let's say the correlation ID should be equal to our message envelope and the correlation ID. So let me just log this additionally somewhere here. So for example, like this, correlation ID, and then our correlation ID value. Okay, so this one looks so far so good. Now also keep in mind that in order to support both synchronous and asynchronous correlation ID passing, just to, do not forget about this one, let's just call this use correlation ID middleware pretty much everywhere. So in our notifier, let's call this one within our weather microservice as well. So let's say somewhere here. And let's also add this middleware to our aggregator microservice, which is here. Okay, so what we should be able to achieve now is actually passing this message in both ways, synchronously and asynchronously. So what I will do now is actually start a few services. The one last thing is to jump into our Pulsar message publisher. And here we'll like to pass along this correlation ID value. So now the question is, how can we actually get this correlation ID value? So there are two ways. So in first scenario, we will receive this correlation ID value within the scope of the ongoing HTTP request. So what I can do is I could inject iHTTP context accessor. So this is the built-in interface to accessing the HTTP context outside of the actual controller or endpoint or minimal API scope. So I can inject it, and this will give me back my context, of course, as long as this context is available, as long as I am within my HTTP context. So what I can do is the following. I could try to call my context get correlation ID, and if it's not present, I could just generate this ID on my own. So let's say if I'm within the scope of the correlation ID and I can get this ID, that's okay. If I'm out of the scope, I could just maybe create this ID. However, once again, we could even refactor this specific component to the actual, we could actually refactor this to the specific component responsible for generating, holding, and returning to us this correlation ID, whether it was fetched from the request header or generated on our own. We could just extract it to some additional component, but just to keep things simple, I will just keep it there. So we could do it this way. So I will either pull this one from my HTTP context, or I will either generate this correlation ID on my own. And finally, we have to include this within our metadata. So within our subscriber, we were using this correlation ID as our property name. So let me just put it there like this. So the correlation ID will be equal to our correlation ID value. And just to be able to actually inject this HTTP context accessor, we need to add this extension. So maybe to our extensions, let's say in observability, but we can actually put this whenever we want, or in a program CS, we could just do something like add HTTP context accessor. And let me just call this pretty much anywhere. So in our notifier, also in our weather feed, and in all the other places, so we can access this HTTP context accessor whenever we want to. So let me put it also there within our aggregator. Okay, so yeah, let's give this one a final try. So now let's start a few services. So the gateway, and now I'm going to start the quote service as well. And of course, I need two more. I need my notifier and I need my aggregator as well. So we should see now that if everything works as expected, that correlation ID will be also passed asynchronously by using our message broker and its metadata properties for the specific messages. Let's hit our quotes microservice first. So as you have already seen, we are just passing through this in a synchronous manner, so it's all good. Now our quotes microservice is pushing some data for Redis. Our aggregator in a moment should be able to publish its very first message. So there is our correlation ID 49D. We send it, and as you can see, we have sent it, and then there is our subscriber. There is our 49D, which is great. And finally, we are wrapping this message payload within this custom envelope. We are calling our message handler. There is our correlation ID, and we can do whatever we want with our message, as we were able to do in the previous episode as well. But now we have a way to actually pass further this correlation ID or any kind of metadata that we want to pass along with our message. So just to keep in mind about the correlation concept is that you need to handle all the possible scenarios, the synchronous scenario and the asynchronous scenario. And luckily, since we already mentioned the concept of observability, there is this very nice library, this actually kind of schema, which is agnostic per language, which actually has different implementations per different languages called OpenTelemetry. And you can find the .NET version out there with the stable production-ready packages. So you could use this to actually make use of concepts like correlation, tracing, monitoring, logging, and all these great features of observability. I didn't want to talk about this in this episode because this is like let's say a topic for at least a few hours, but just to give you a glimpse of how to even start thinking about some kind of metrics, tracing, or observability in general, the correlation ID concept is really something to begin with. And one more great thing is that there is this activity class built into the framework and actually into the system SDK. So if you would like, you could actually even skip this custom correlation ID part. So just to show you how easily you can make use of the system activity is the following. Let's jump into our gateway once again, and let's take a look at the following. So activity equals system.activity, or actually diagnostics activity. So let me just activity.current, okay? And let me just do the same within our quotes microservice so we can observe something very nice. And let's just start our gateway and quotes. And let's take a look at this activity current. So as you will notice, this will give us this correlation feature out of the box. So let's make this request once again. Let's do this pricing star request. And there is our activity from the gateway. Then there is our unique activity ID sent by the gateway. As you can see, this is the unique ID and this is this so-called root ID. So let's just send this request further, okay? So we are now hitting our quotes microservice, and let's take a look here. So the activity for this one is, as you can see, the same, this root ID, as it was within our gateway. So this root ID has been passed kinda magically out of the box through this HTTP. So if you are working with the HTTP request, you can just use this activity and you can extend this activity with lots of different properties that you can later use, for example, for the metrics or tracing purposes. But once again, this is just a glimpse of what you can also achieve with the built-in system components. But just to begin with, slowly, start with the activity, write your own correlation ID wrapper or use the existing activity component. You can read more about this within this official documentation. There is a lot of great samples out there, and just make sure that you can handle all the possible cases, all the possible protocols, synchronous and asynchronous ones, to never lose track of your correlation, whether you are sending synchronous requests or asynchronous messages between your microservices. Okay, so hopefully by now you have realized how important it is to have this correlation in place. And like I said, I really want to emphasize this. If you don't have some kind of correlation identifier and you have microservices, you should really add it as soon as possible. Because without the correlation ID, it's really hard to think about stuff like observability in general, which allows us to somehow observe our system pretty much in real time and even react before things start falling apart. Just keep in mind to not forget, to not lose your correlation ID when you are sending both synchronous and asynchronous requests. But as you have seen in this episode, there's multiple ways to achieve this, using HTTP headers, AMQP headers, metadata being part of your specific message broker. So it's pretty much, I think it should be possible in pretty much any case, regardless of the particular tools, message broker, service bus that you might be using. And yeah, once you have this in place, you could take a look at the system activity. But like I said, the system activity is a very helpful class, but there is much more to that than just having this class and some set of identifiers within. We could use it for much more interesting topics, like for example metrics, or later on for tracing, which is actually beyond the scope of this episode. So something like for the dedicated, let's say, observability series. So yeah, thanks for watching as always, and subscribe if you haven't already. Check us out on Instagram and other social medias, and see you in the next one.